Good morning. Let me share the lab manual and I answer your questions first. Have any questions, any concerns before we start the experiment? Good morning. Any questions for me?
Yeah, about the video, I don't know if you know this, but the video disappeared. The experiment disappeared yesterday.
I know. What happened, they deleted anything I had in Blackboard Collaborate. And they, since they deleted the source or the content in the source for me, the links were not working, but I was working on them to this morning, and for your class, I actually added all the links. So I had to have the videos in YouTube and get the link from the YouTube and post it. So if you see, there are two links for the experiment. One is like a link and the other one is video. Click on the video or click on both. One of them should work. I am cleaning up the course, so removing the old links, so only the new links would work, but I have both of them just for now because I didn't have time to work on all the courses. I just finished 1045 and 1046 lab today, so I have to do the same for my other classes as well, but it should work. So if anyone can try to see if the link is working, that would be nice, and let us know. Now, since it was not up yesterday, so I will give you extra day to turn in. The assignment is set up so it does accept late submission, and I think it's set up until 11:30 p.m. to take the new submissions. But if you definitely need like 24-hour, I can make it, I can change that to like tomorrow. But if you can do it today, then I don't have to make any changes. Let me just double check to make sure that the time is actually, this would be for experiment 6, right? The data sheet for experiment 6 and pre-lab, but you don't need the pre-lab, right? You don't need the videos for pre-lab. No. It's just a data sheet for experiment 7. Let me go ahead and extend that for a day, so there would be no problem. Okay. Data sheet for experiment 6. Most of you have submitted, and it does take more than one submission, and it allows you to submit late. It's just that if you submit it until like tomorrow, I won't take points off. Is that okay? Would that work? For anyone who didn't finish it? Yes? Okay, good. For anyone who did not finish it, you can go ahead and finish and submit, or if you submit it incomplete, you can finish it up and submit again. If the data sheet for experiment 6, if it's submitted by tomorrow night, it will not count late. Okay. Any other questions? But it was like a good, I don't call it stress, but it was a, you know, it's something that I was worried about, students who, you know, would need to use it, and then I had to create those links. It's just, it takes time to upload new videos. So it's done. Luckily, at least for your class, it's done for sure. All of them, all experiment 7, 8, and 9. You have today and 2 more experiments, right? Yeah. We're doing experiment 7 today. And this is experiment 8, 9. And your final exam is going to actually be on the 13th. Okay. Any other questions for me? No? Okay. What is the purpose of today's experiment? the purpose for today's experiment. The difference between heat capacity and specific heat. Specific heat has a unique definition. Can anyone define a specific heat? What is a specific heat? What's the value for a specific heat for water? Specific heat is 4.18 joules. What's the unit? Joules per what? No.
Joules per gram degree Celsius?
Yes, joules per gram per degree Celsius. And the heat capacity is the joules per degree Celsius. So heat capacity is used for the body of, let's say, calorimeter or body of that, whatever you're dealing with. For everything includes all the mass. But as long as the temperature changes by 1 degree, how much heat is needed to increase the temperature by 1. But when you talk about a specific heat is specifically defined for 1 gram. So is the amount of heat needed to increase the temperature of 1 gram of substance by 1 degree Celsius. So if you have 4.18 joule per gram per degree Celsius, that means that it's 4.18 joules is needed to increase the temperature of 1 gram of water by 1 degree Celsius. Now, if you have 10 grams of water, then you need more heat. If you want to change the temperature by 5 degrees Celsius, then you need more heat. But a specific heat just is the unit, kind of the unit. It clarifies that is for 1 gram only and change in temperature by 1 degree. But the heat capacity, the unit is joule per degree Celsius, and that means that it's like if you're talking about the calorimeter, a specific heat or heat capacity for calorimeter, it includes like the entire sample. I hope that explained. Okay. Any other questions you might have? So what is the purpose of the experiment today? Yes.
It's to learn how to calibrate and use a calorimeter to determine enthalpy changes for 2 different reactions.
That's one part. Yes. What else?
And it's to use Hess's law of heat summation to indirectly determine enthalpy change for a combustion reaction.
Very good. Very good. You want to determine the delta H, or change in the amount of the heat released per mole. If you say delta H, is like per mole. So if you want to Q, it's for given mass, but H or delta H for a reaction is like per mole. So you have these numbers recorded often, and you can calculate them when you are performing the experiment. Sometimes it's not easy to determine how much heat was released when something is combusted, like magnesium is combusted. How do you record the temperature change? You can do that, like when the temperature, when the heat release is going to increase increase the temperature of the water, like the other experiments that you're doing for magnesium in HCl. But it's not convenient and to do it in the lab. Like if you use that heat to increase the temperature, there would be a lot of waste of the heat to environment. So indirectly, you want to determine the delta H. How do you determine delta H? you're using a couple of the facts. You're saying that if you reverse the reaction, the value for delta H is going to be, the sign for delta H is going to be reversed. So if you have copper sulfide decomposed to copper plus sulfide, now if you reverse this reaction, change the arrow sign here, you have to also change the sign for delta H. So you combine copper and sulfur to get copper sulfide as a product. You will get heat. The heat would be released. But if you have copper sulfide and you want to decompose it to copper and sulfide, you have to use energy, and you have to use energy. Okay, the other facts from the Hess's law. If you multiply a reaction by 2, what happens to delta H? If you multiply a reaction by 2, then the delta H value is going to be also multiplied by 2. If you add 2 reactions, what happens to delta H? If you add 2 reactions, the delta H values also will be added, right? The delta H values also will be added. So we have to look at if you reverse it, the sign would be opposite. If you add 2 reactions, it will be added. And how do you add 2 reactions? Can you tell me how you add 2 reactions? It's something simple, and that's all about the Hess's law. I mean, have to reverse the reaction, have to multiply by 2. If you multiply by 2 this reaction, for example, this reaction, you have to use 2 Fe2O3. That will give you 4 Fe's and 3 of O2. Right? And then this number would be multiplied by 2. But if you're adding 2 reactions, can you tell me how you add 2 reactions?
You can't see your screen, Professor.
It's not shared anymore? Nope. Sorry. Okay. Just a minute. Okay. How do you add 2 reactions? Look for the same element on the same side. You combine different sides, subtract.
Yeah, don't you have the smaller, the larger number and the smaller of the change in H, and then flip it around so that the reactant forms to the product side?
Okay. That is, we are taking one step at a time, so we know that everyone is clear. Like if you reverse the reaction, that means you put the products in the reactant side and reactant on the product side. The sign for delta H would be opposite, right? We're just talking about the initial steps.
Okay.
If you multiply reaction by 2, that means you use double of the moles of comparing based on the stoichiometry of the reaction. You would use double the moles of reactant and product, then delta H value would be 2 times. And if you divide by 2, delta H value would be divided by 2. What I'm saying now is again another initial steps or baby steps. If you add 2 reactions together, what's going to happen to delta H? You also add algebraically, you add the delta H's as well. Now, how do you add 2 reactions? To add 2 reactions, you are going to, this is how I do it, and it makes it simple, just like what Neil explained, also very similar. So if I'm trying to add these two reactions together, okay, I'm going to draw one arrow sign here. Just draw arrow sign. Put anything that is on the reactant side on the reactant side. Anything that appears on the product side, I put on the product side. Then simplify it. If you have same element or like terms, it can add up. If you have like terms on the same side, you will add up. Or if you have like terms in opposite side, one on the reactant, one on the product, then it would cancel. Which one did cancel in these two reactions? Which element actually canceled? Which compound or which substance canceled? Oxygen, right? You have oxygen on the reactant side, you have oxygen on the product side. So the oxygens are going to cancel. But Fe2O3 is going to go to the reactant because it's on the reactant side. CO is going to go on the reactant side because you have three of them. You say three. On the product side, Fe would appear because it's on the product side. And then CO2 appears because it's on the product side. So we have everything on the product side. We write on the product side, everything on the reactant side of all reactions when you are adding. And what happens for delta H? For delta H, then you have to add them algebraically. You have to make sure the sign for the plus and minus is correct. I think there is a typo there, right? There is a typo because we have this on the product side. So 849 should be negative. 849 should, right?
Yes. You have to flip the signs. Hold on.
We are not flipping the sign. It's just a typo. It's just a typo, and I'm going to write here for my.
Oh yeah.
I said something earlier. This is for 1046 lab manual, page 99. I have to change the sign, delta H sign, for reaction of 3CO plus the other one, the oxidation, the combustion of the CO gas changing to 3CO2. I have to change that sign. It's a typo. That should be negative because the overall answer is negative here. So you add the two together. And yes, you see, it's a negative sign here. It's here, we have 283, okay? 283, how come we have 849 here? What happened? CO going to CO2, it releases 283 kilojoules of heat. What happened here that we have 800? You multiply the reaction by 3, you multiply the delta H value by 3, and the typo is right here that this should be negative because you only multiplied it. You didn't reverse it. The CO2 is on the product side. So it's just a typo, and I wrote it down, and it will be fixed for the next edition. But make sure that you make a note of it, that if you multiply, you only multiply the numbers, the sign would stay. The only time that the sign would change is if you reverse it. Okay, so this is an example of you're trying to find this delta H for this reaction, and you have these two reactions. It's saying, how are you going to change these two reactions in order to come up with this? Okay, so you have to see, this is your final reaction. That's how you want your reaction to look like. Okay, and these are the two reactions that you can do whatever you want with them. You can flip them, you can multiply by 2, 3, whatever number needed, or you can divide. So I look at the first reaction here. It says that I have Fe2O3 on the product side. Well, desired reaction, it says Fe2O3 must be on the reactant side. So I know that's how I recognize that I have to flip the first reaction, because this has to be on the reactant side. What else you recognize there? What else I should do besides flipping? How many Fe2O3 do I need on the reactant side? Only one, right? I need only one. So if I need only one, what should I do? I have to multiply by 1/2, or I have to divide the whole reaction by 2. So if I divide the reaction by 2 and flip it, when I flip it, the sign would be positive. So you see this 822 is positive. And when I divide this by 2, I also divide the delta H by 2. 1644 changes to 822. So how do I know I have to flip it? Because Fe2O3 must appear on the reactant side. How do I know I have to divide by 2? Because I only need one of these and only 2 Fe. Here I have 4 and I have 2. And do I have to worry about the O that is going to be 3/2? No, because it doesn't appear in the main reaction. So I don't have to worry about this. Hopefully somehow it's going to be canceled. Now, what should I do to my second reaction? Do I have to flip it? Do I have to reverse the reaction? The highlighted reaction.
You need to, yeah, you'd need to flip that.
Why should I flip it?
Oh, no, you don't.
Okay, perfect. I don't have to flip it. Why not? Because the CO2 is on the product side and CO is on the reactant side. That's what this reaction is showing. CO is on the reactant side and CO2 is on the product side. Can I use this reaction the way it is?
No.
Any changes should I make to this?
Well, yeah, you'd have to make changes to the CO because it's.
Thank you, Naya. Yes, Naya. What we have to do is multiply by 3, right? That's the change you're talking, Andre, right? We have to make changes to match with our final reaction. Our final reaction requires 3 CO, 3 CO2. So we have to multiply this by 3. If we multiply the reaction by 3, we also multiply the delta H by 3, and that is minus 849. There is a typo. Please make note of it, and I will fix it. Okay, so you have to flip the first reaction, divide by 2, flip the sign, divide by 2, the value of delta H. For second reaction, you don't reverse it because product is in the product side and the reactant is on the reactant side. O2, I don't have to worry about it because it doesn't appear in the main reaction. Then I have to multiply by 3 because I need 3 of them in the main reaction. Okay, now after you make the changes, then you add them together. When you add these 2 reactions together, you also add the delta H values, and based on that, when you are adding reactants, you write the reactants on the reactant side or to the left of the arrow sign, and the product on the product side to the right of the arrow sign. Anything that can be canceled, you can cancel it before even bringing in, or you can bring it and then cancel the like terms from both sides of the reaction. So if you have 3O2 on the reactant side, 3O2 on the product side, it will be canceled. Okay, any questions about application for Hess's law and some of the rules that it comes with the Hess's law? So these are the 3 that we were talking about. Okay. If you have a substance that it appears in this initial reactions and it doesn't appear on the main reaction or overall reaction, somehow they need to be cancelled. For reversed, delta H would be reversed, the sign would be reversed, and if you multiply or divide by any factor, you have to multiply and divide the delta H value by that same factor. Okay. So we talked about the difference between heat capacity and specific heat capacity. Heat gained and heat loss would be equal. From when you have copper, hot copper and cold water, you mix it together. Heat gained by water would be equal to heat lost by the hot copper, and you can use that to determine specific heat. If you have the specific heat, you can use the equation and find the Q of the calorimeter. So this way you can do your calculation based on the heat or heat capacity of the calorimeter. And the reactions that are, this is our overall reaction. The reactions that we have, are these three reactions that we have, delta H 2, 3, and 4. Delta H2 is a given number. Just know that this value is given to you. Delta H3 and delta H4 are determined experimentally. So you find these values, and this value is given. Then you rearrange these three reactions in a way to come up with this reaction. So I would keep this reaction forward, don't reverse it. I would reverse this reaction because MgO is on the product side, and O2 is on the reactant side, so I will keep it in the reactant side. So this reaction also is going to be straightforward, but since I need half O2, I have to divide this by 2. And then you add them all together. But experimentally, you have to find the values for delta H3 and delta H4. So for part 1, which is the calibration of the calorimeter, that's where you find the heat capacity for calorimeter. And if you didn't do this part of the experiment, you can just say the heat loss to calorimeter is considered 0, and then you would calculate the delta H value based on the Q of the reaction. And what is Q of reaction is the amount of the heat that is released in the reaction. That would be mass. Q equals mass times specific heat times change in temperature. And mass is the total mass of the liquid that you have in the calorimeter plus the mass of the magnesium if you're adding magnesium. I think this reaction requires a percent calculation, and for the percent calculation, I have to give you a number. Let me see. Okay, the number I wrote it already. So because in the past it was asking me to give you that number. So the number that you find at the end should be close to this 601 kilojoule per mole, and if it didn't, if it was like double that number, then something is wrong. So you have to recheck your calculations. Do you have any questions for me? No questions? Okay. If there is no questions, you know what's coming next, right? Did anybody check to make sure the video is working for experiment 6, please? I already posted. Yes, it's working. Perfect. So if experiment is working for 6, and it should work for experiment 7 also, because I uploaded the same way. And if it doesn't work, just send me an email. I will check it for you to make sure that it's working. The links should work, and I have to do the same for other classes that are taught by other faculty. So I will be busy. I was hoping I start grading today because I didn't grade much papers last week, but I promise this week again I have to do a lot of grading. So by end of the week or by end of the weekend, I should have most of the papers graded for you. Megan, this is for attendance.
Here.
Thank you. Tiziana.
Here.
Juan. Juan.
Here.
Thank you. Saima. Robert. Is Saima here? Natalie.
Here.
Aline. Janelle.
Here.
Thank you. Let me see if Saima signed into there or not. Saima. Okay. Caitlin. Isabella.
Here.
Mia. Andre. Camilla. Kaylin.
Here. Here.
Okay. Jonica. Alex. Alex. Crystal. Alana. Thank you. Alana. Naveed. Did you respond, Naveed? Daniela. Luke.
Here.
What about Daniela? Naveed. Daniela. Saima. Naya.
I'm here. Simon's here.
Saima is here. Okay. Yes, I got you, Nia. Sabrina. And Yubin. Okay, people who signed in but did not respond. Luke, I got you, right? You already responded?
Yes.
Okay. Naveed? Okay, you signed in, but you're not responding. Send chat message. Otherwise, I have to mark absent. Did I call everyone's name? Juan, did you respond? Yes. Yes, you did?
Yeah,
Okay,
yeah,
for a 10? Okay, perfect. Sorry. Okay. If you don't have any questions, thank you. And have a nice day. If you have questions, you may stay and ask your questions. If not, please watch the video. Thank you. Bye. Have a nice day. Let me know if you have any questions.